Classifying quadrilaterals. A quadrilateral is a polygon with 4 sides. It can be concave, convex, simple, complex, regular, or irregular. But it must always have 4 straight lines for sides. Every quadrilateral has 4 sides. These are called edges. 4 corners. These are called vertices. And 4 angles. The angles inside a quadrilateral always add up to 360 degrees. For example, in a rectangle, all 4 angles are 90 degrees. 90 degrees plus 90 degrees plus 90 degrees plus 90 degrees equals 360 degrees. But this is true for every quadrilateral, not just rectangles. 92 degrees plus 66 degrees plus 128 degrees plus 74 degrees equals 360 degrees. Classifying quadrilaterals. Every 4-sided figure is a quadrilateral, but there are some specific, special quadrilaterals. 1. Parallelogram. A parallelogram has 2 pairs of parallel sides. Parallel means the lines never cross, like railroad tracks. In a parallelogram, the sides across from each other are not only parallel, but they are also the same size. 2. Rhombus. A rhombus is a parallelogram that has 4 equal sides. That may sound like we're describing a square, but as you can see, a rhombus isn't necessarily a square. A rhombus typically looks like a square that is slanted. 3. Square. You should recognize a square, but you might not recognize its definition. A square is a parallelogram with 4 equal sides and 4 right angles. Remember, right angles look like a perfect corner. 4. Rectangle. You should also recognize a rectangle, but let's look at its definition. A rectangle is a parallelogram with 4 right angles. Notice that the definition of a rectangle doesn't say anything about the length of the sides. That's because not all the sides are equal. However, because it says it's a parallelogram, that means the sides opposite of each other will be equal, which you already know since you know what a rectangle looks like. 5. Trapezoid. A trapezoid has only 1 pair of parallel sides. Remember that a parallelogram has 2 pairs of parallel sides. In contrast, a trapezoid only has 1 pair. And there's no guarantee that any of the sides are equal. 6. Kite. A kite has 2 pairs of equal sides, but the equal sides are right next to each other. That's different than a parallelogram, which has equal sides, but they are across from each other. The diagonals of a kite, shown in the picture with dashed lines, always makes a right angle. Let's see what you have learned in this lesson.
Previously, we looked at the basics of quadrilaterals. Now we will study their different types. Look at this quadrilateral ABCD. In this quadrilateral, this pair of opposite sides is parallel. AB is parallel to CD and the other pair of sides is non-parallel. So AD and BC are the non-parallel sides. This kind of quadrilateral where only one pair of opposite sides is parallel is called a trapezium. Sometimes the non-parallel sides are equal. The quadrilateral would look something like this. AB is parallel to CD and AD is equal to BC. These two sides are equal and non-parallel. Such a trapezium is called an isosceles trapezium. So remember, a trapezium will have one pair of parallel sides and the other pair will be non-parallel. And if the non-parallel sides are equal, then it's called an isosceles trapezium. Let's look at another type of quadrilateral. It's called a kite. We all know that a kite looks something like this. If we draw, it will look like this. Let A, B, C and D be its vertices. In this kite, these two sides are equal and these two sides are equal. This is one adjacent pair of sides and this is another pair of adjacent sides. So we can say that in a kite, two pairs of adjacent sides are always equal. The first pair of sides which are equal are AB and AD, and the second pair of equal lengths is CB and CD. Some definitions also say that the opposite sides of a kite are unequal. AD will not be equal to BC and AB will not be equal to CD. We have now covered the basics of trapezium and kite, and we will cover more types of quadrilaterals in the coming videos.
In this video, we will learn all about trapezoids. A trapezoid is a quadrilateral, which means it has four sides, and it has one pair of parallel sides. So that's what a trapezoid is, a quadrilateral with exactly one pair of parallel sides. The reason it has to be exactly is if the shape has two pairs of parallel sides, then it's a parallelogram. So trapezoids have exactly one pair of parallel sides. The trapezoid doesn't have many special or interesting properties, but there is a special type of trapezoid called the isosceles trapezoid, which does have some properties. If you remember the word isosceles from isosceles triangle, you'll remember that it has to do with two sides being the same length. Therefore, an isosceles trapezoid is a trapezoid where the non-parallel sides are congruent. So this would be an isosceles trapezoid. In an isosceles trapezoid, the two parallel sides are called the bases. So the trapezoid has two bases. The angles at the bottom along the longer base are called the base angles. The congruent sides are called the legs. So these two sides are the legs. In an isosceles trapezoid, the base angles will always be congruent. Also, the diagonals, if you were to draw those in, will also be congruent. So this diagonal is the same length as this diagonal. All trapezoids, whether they are isosceles or not, will have something that's called a midsegment. What the midsegment is if you take the two non-base sides and find the midpoint of each, so the midpoint of this side and the midpoint of this side, and connect them, you will have the midsegment. So remember, because these are each midpoints, we have some pairs of congruent segments there. And again, that is called the midsegment. Now, the length of the midsegment will always be the average of the length of the two bases. So that means if you want to find the length of the midsegment, you would find the length or be given the length of both bases, add them up, and divide by 2. This works again whether or not the trapezoid is isosceles. So for example, if the top base was length 8 and the bottom base was length 14, to figure out the midsegment, you would do 8 plus 14 and divide that by 2. And since 8 plus 14 is 22, and 22 divided by 2 is 11, the length of the midsegment will be 11. In this video, we will look at 2 examples to practice working with trapezoids. In example A, it says, look at trapezoid TRAP below. What is the measure of angle A? So we're trying to figure out this angle right here. The first thing I notice about this trapezoid is it's marked as having 2 sides that are congruent, and those are the legs of the trapezoid. Because those 2 sides are congruent, it means that this is actually an isosceles trapezoid, and so its base angles will be congruent. That means each pair of base angles will be the same measure. So the 115-degree angle, angle T, will be congruent to angle R. So angle R is also 115 degrees. And angle A and angle P will also be congruent. Another thing I know is that the 4 interior angles for any quadrilateral will add up to 360 degrees. So that means these 4 angles must add up to 360 degrees. So if I call angle A x, then angle P will also have to be x. And I know that when I add all of these up, 115 plus 115 plus x, that has to equal 360 degrees. Now I can solve this equation for x in order to get my answer. So combine like terms, and you get 230 plus 2x equals 360. Then minus 230 from both sides, and you get 2x equals 130, which means x equals 65. So our answer is the measure of angle A, which we defined as x over here, equals 65 degrees. At this point, let's jump to example C. In this example, it says, find x. All figures are trapezoids with the midsegment. So remember what a midsegment is. It's the segment that's created when you take 2 midpoints of the legs and connect them. So because that's a midpoint, it means that this segment would be congruent to this, and this congruent to this. Now, the way it works is that the mid-segment, the length of the mid-segment, is the average of the length of the bases. So for the first one, since we're trying to figure out the actual mid-segment, we take the two bases, which are 12 plus 26, and average them in order to get x. So 12 plus 26 is 38, and 38 divided by 2 is 19. So that means x equals 19. And if you think about it, that should make sense because 19 is the number exactly in the middle of 12 and 26, and it should look like the mid-segment is in the middle of the lengths of 12 and 26. All right, now for part B, we're asked to find one of the base lengths. So x is going to be in a different part of our equation. 24 is the length of the mid-segment, which means that 24 is the average of x and 35. So x plus 35 divided by 2 has to equal 24. This is an equation we can solve. The first thing we should do is multiply each side by 2, and that cancels out the dividing by 2. So we have x plus 35 equals 48. Then we just have to minus 35 from both sides. And we get that x equals 13. And again, that should make sense. It definitely should have been a number smaller than 24 and 35. And the difference between 24 and 35 is 11. And the difference between 13 and 24 is also 11. So it makes sense. In this video, we are going to learn all about kites. A kite is a special type of quadrilateral. That means it has 4 sides. And what makes this quadrilateral a kite is that it has 2 pairs of adjacent congruent sides. So 2 pairs of congruent sides that happen to be next to each other. That's what the word adjacent means. It means next to. So the 2 sides that are congruent are touching each other. Now a kite has some interesting properties and parts that we need to know the names of. The first is that the angles that are between the congruent sides, so this one and this one, are each called vertex angles. They are not going to be the same measurement. The other angles, the non-vertex angles, so that would be this one right here and this one, they actually are congruent. So one property of a kite is that the non-vertex angles will always be congruent. Another property has to do with diagonals. So if we draw in the diagonals, one thing we should notice just by looking at it is that those diagonals are perpendicular. So that means that they meet at a right angle. So the diagonals are perpendicular is another important property. Remember that that symbol for perpendicular is the upside down T. Now, while these vertex angles were not congruent, when we have the diagonals drawn in, that long diagonal actually bisects the vertex angles. So what that means is that this angle is congruent to this angle over here. It's been cut in 2. And similarly, this angle will be congruent to that angle there. So the diagonal bisects the vertex angles. It doesn't, the other diagonal does not bisect the non-vertex angles. The last property is that the long diagonal, so I mean this diagonal here, bisects the short diagonal right here. So what that means is that this segment will be congruent to this segment. So the long diagonal bisects the short diagonal. So that's what a kite is. It's quadrilateral with two pairs of adjacent congruent sides. Don't forget that word adjacent means next to. And it has four important properties: that its non-vertex angles are congruent, its diagonals are perpendicular, the diagonal bisects the vertex angles, and also the long diagonal bisects the short diagonal. In this video, we will look at a few examples that will let us practice working with kites. In example A, it says, find the other two angle measures in the kite below. And it's given that we have one 130-degree angle and one 60-degree angle over here. Now, one property of a kite is that the non-vertex angles, which would be these angles, are always congruent. So that means that they will be the same measure. Another thing you need to know is that for any quadrilateral, the four angles will add up to 360 degrees. So that means the 130-degree angle plus the 60-degree angle plus these two unknown angles equal 360 degrees. So let's call the angle that we don't know x. And that means this angle will also be x. So now what we know is that 130 plus x plus 60 plus x must equal 360 degrees. And we can solve that angle for x in order to find the answer to the question. So when we solve this, we should start by combining like terms. 190 plus 2x equals 360. Then minus 190 from both sides. And we get 2x equals 170, which means that x equals 85. So that means the other two angle measures, which were the missing ones in green, are each 85 degrees. Okay, let's look at example B. Use the Pythagorean theorem to find the length of the sides of the kite. So one thing about a kite that you should know is that its diagonals are perpendicular. And it's been marked like that because there's a right angle, but you should know that this would be true about any kite, that there would be a right angle there. So we can use the Pythagorean theorem to find these missing sides. Let's first start by finding the length of this segment. So we're going to call this side C because it's the hypotenuse, because it's across from the right angle. So the Pythagorean theorem is a squared plus b squared equals c squared, where c is always the hypotenuse. So to find c in this case, we're going to do 5 squared plus 12 squared equals c squared. That means 25 plus 144 equals c squared. Because 25 plus 144 is 169, that means 169 is c squared. Square root both sides and you get c equals 13. C could technically also equal negative 13, but that doesn't make sense in the context of this question because you can't have a negative length. So that means each of these sides are 13. Next, let's find the length of the other missing side. Again, this side is the hypotenuse, so we'll call it C because it's across from the right angle. So the equation this time will be 5 squared plus 6 squared equals c squared. 25 plus 36 equals c squared. So that means 61 equals c squared, and c equals the square root of 61. So that would be the missing side for here and also for here. All right, let's finish off with example C. Find the other two angle measures in the kite below. So we're given a 94-degree angle and also a right angle, which would be 90 degrees. Now remember that the non-vertex angles, so this angle and this angle, are always congruent. So that means This angle is also 94 degrees. The last thing that we need to remember is that the four angles in any quadrilateral add to 360 degrees. So if I call this angle x, I can add up 90 plus 94 plus 94 again plus x equals 360 degrees and solve that for my missing angle. When I combine like terms, I get 278 plus x equals 360. Minus 278 from both sides, and you get x equals 82. So that would be this missing angle. So the first missing angle was 94 degrees, and the second one, using the fact that they all have to add up to 360, has to be 82 degrees.